Okay, so in the latest installment of Mr. Robinson sitting in a room and talking to his iPad while showing you how to solve a problem, we'll be looking at balancing equations and stoichiometry. So this is sort of a typical straightforward stoichiometry problem. Write a balanced equation for the combustion of methanol and find out how many grams of H2O are produced if you combusted 20 milliliters of methanol with a density of 0.791 grams per milliliter. So the first thing we need to do is we need to get a balanced equation for the combustion of methanol. At this point you don't necessarily know everything you need to figure that one out, but we will in the not too distant future have memorized what a combustion reaction was and therefore be able to create this. So for now, simply combustion with oxygen gas. So methanol is going to be CH3OH, and we're going to combine that with oxygen gas. And that's going to form CO2 and H2O. Combustion of any hydrocarbon will form that. Okay, we now need to look to balance this. So first thing I'm going to do is make sure that the carbons are balanced. I have one on the left, one on the right, so that's good. I'm then going to take a quick look at the oxygens. Not the oxygens, I take that back. Let's make sure the hydrogens are right first, because we have only one hydrogen, one molecule with hydrogen on this side, one molecule with hydrogen on that side. So we take a look at that and we simply say, okay, I've got 4 hydrogens on the left, I have 2 on the right, so I'm going to need to double that, 2 H2O. Okay, now since we have oxygen in every molecule, but the CO2 is fixed by the carbon, the water is now all set to balance the hydrogen. Really the O2 is the only thing that I can play with for the oxygen, so that's where we're going to balance out the oxygen. Now if you look on the right, currently we have 4 oxygens, 2 waters, each has 1s, there's 2, and carbon dioxide has 2. So we have 4 oxygens right there. On the left, we have the 1 in the methanol. That means I need 3 more. There's a couple ways we could do this. We could sort of go up to bigger numbers to make it nice and whole, or we could simply say 3 halves O2. Okay, saying like molecular oxygen, which is in the form O2, half of an O2 would be an O, 3 of them, there you go. You could also just multiply the whole equation at this point now by 2 to get 2CH3OH plus 3O2 goes to 2CO2 plus 4H2O. I'm just going to leave it as it is for now, but just know that that's the possibility if you want to get everything to whole numbers. Realistically, you're not going to have halves or 3 halves very often, except for pretty much in the case of things like oxygen, nitrogen, N2, hydrogen, H2, etc. So, given that we have this situation now, shrink this up here just so we can still see it. Alright, and now we're going to go and get to work solving this problem. So every stoichiometry problem breaks into 3 problems. Okay, the first thing is to find a way to get it into moles. The second thing is to use the equation that we just balanced to convert moles of one compound to moles of another. And then the third part is to take that moles of the other that you just found and convert that into whatever the final answer should be. Grams, milliliters, liters if you're dealing with gas, pressure, whatever. Okay. In this case we have 20 milliliters of methane and we have a density of 0.791 grams per milliliter. So what we can do is just start converting our methanol here. 20.0 mils of methanol. And we can simply convert that into grams by, we know the conversion of 0.791 grams per 1 milliliter, okay, for methanol. So now we have grams of methanol, and we know that we want to go to moles of methanol, so I'm simply going to say, all right, that means that we have 1 mole of methanol. And we're going to use the molar mass of methanol, which I've already calculated to be 32.01 grams. And at this point, we are going to go ahead and take a calculation, and we get 0.493 moles of CH3OH. So that's our starting point. Okay, we have found out the moles of methanol. That's part 1. Technically, the 32.01 should be 32.04 grams. Sorry about that. I read wrong from my notes here. So then we get 0.493 moles of methanol. Now I want to go from moles of methanol to to moles of water in this problem. And then from moles of water, we know how to find grams. So I'm going to use this equation as my conversion factor, right? You can see right here, methanol has essentially a secret 1 there as its coefficient, and the water has a 2. So that's what we're going to use here to make our conversion factor, this 2 and this 1 from the balanced equation. So remember, the equation always has to be balanced first before you can use it. So at this point now, we take our 0.493 moles of methanol, CH3OH, and okay, I'm trying to convert to moles of water. So moles of water goes on the top, moles of CH3OH on the bottom, and I just look at my equation. I can see that I have 2 moles of water and 1 for every 1 mole of methanol. Okay, this is also true for molecules. Remember, we can't go grams to grams here because as we're balancing this, this is balanced by molecule and therefore by mole. Okay, but not by grams. So we do that out, and we get that this is now twice as much. So it's 0.986 moles of water. Okay, so this is the second step right here that you do in a stoichiometry problem. You simply take the, just move that out of the way there, you take that moles of one thing that you've input, use the equation to get the conversion factor, convert it to moles of something else. Now at this point, we're going to go from the moles of water, which we found, and finish off the problem by converting that over to grams. So we have our 0.986 moles of water, and we are going to multiply that by 18.02 grams per 1 mole of water. Okay, molar mass of water. And out of this, at the end, we therefore get 17.7 grams of H2O. Okay, so that's how you're going to do a basic stoichiometry problem. Remember, the front part of this, the first part here, could vary. In this case, we were given a density and a volume. You could be given a pressure of a gas. You could just be given grams straight up. The second part here is pretty much going to stay constant, okay, because you're just converting from moles of one to moles of the other. So once you get to moles, it's sort of straightforward and easy. And then the third and last part, oops, that's going to shrink the whole thing, my bad. The third and last part right here, we're simply taking the moles that we got out of number 2 from our conversion from one molecule to the other, and we're going to go back out towards whatever they want. In this case, it happens to be grams. It could also have been find milliliters given a density, like in part 1. Okay, there's a lot of different ways to do that, different things you could be looking for or asking for. So just be aware of that, but they all follow the same basic structure.